As this is the second video of Astable Multivibrator. Now let me see the circuit. I have explained the circuit. It consists of two transistors, four resistors and two capacitors. Now due to non-ideal characteristics of two transistors Q1 and Q2, let me assume that the switch is closed, therefore the VCC supply is turned on, is given to the transistors. Since of interdisciplinary nature, you mean the two transistors is non-identical, let me assume that Q1 turns on first. Q1 turns on first. You see the circuit now, Q1 turns on first. Therefore, there is a flow of current from VCC through Q1 to the ground through resistor RL1, R2 and C1. Similarly, there may be a flow of current from RL2, C2 and Q1. You mean the base of the Q1 is an on condition. Therefore, Q1 is an on and Q2 is an off condition. Therefore, the VCC voltage drops across RL1 and the C1 is in discharging condition. C1 is in discharging condition, whereas the capacitor C2 is in charging condition. Therefore, see the output of the capacitor 1 and capacitor 2. Since the VCC, let me assume it is 5 volt, the 5 volt capacitor voltage is in charging condition in VC2, and whereas in VC1 it is in discharge condition. It is circled here as in red color. VC1 is in discharging nature. Now what happens? See in the next video or next slide. Now what happens once the capacitor is fully discharged? Once the capacitor is fully discharged, the base current is not sufficient for Q1. The base current is not sufficient for Q1. Therefore, Q1 is forced to turn off. Q1 is forced to turn off. Since Q1 is off, then the whole voltage VCC will flow through RL1, C1 and to the base of Q2. Therefore, Q2 is turned on at the same instant while the Q1 is turning off. You mean while the Q1 is turning off, the Q2 is ignites, the sufficient base current is there, therefore Q2 turns on. See the graph. In VC2 the voltage drops. The blue circle indicates the voltage drops in VC2, whereas see the VC1 voltage. See the VC1 voltage, there is a rise in voltage. Here the capacitor C2 is discharging and the capacitor C1 is charging. And this cycle repeats. You mean the turn on of Q1 and Q2 is opposite, and again if the discharging of C2 is fully completed, then again Q2 may be turned off and Q1 is turned on. This cycle repeats such that the output waveform is a square waveform. See here, the output waveform is a square waveform. Therefore, there may be two outputs. One is taken as C1 output, you mean the output at the collector point of transistor 1, and another is the output at the collector point of transistor 2. See here the upper waveform, Q1 is turned off as I discussed earlier. The first state, Q1 is turned off. The upper waveform, the Q1 collector output is maximum, you mean it is VCC, and when it is turned on, the voltage drops. I have already explained in the characteristics of a switch such that when the transistor is in on condition, the collector voltage is almost zero, and when the transistor is in off condition, the voltage across the collector is maximum. the voltage across the collector is maximum. Therefore, the Q1 collector waveform is almost opposite to that of the Q2 collector waveform. Therefore, the output of a stable multivibrator, you mean we get two pulses, two pulse output, one at the output at Q1 and another in the output at Q2. Thank you for patient listening. The real-time application is also given. See here the real-time applications. What is seen here is nothing but the real-time applications. See here, a vehicle indicator and timing pulses, the real-time applications. Thank you for patiently listening.